Hi, welcome to the fourth segment of our PADT webinar series about the Stratasys Origin 2 DLP printer. PADT is Phoenix Analysis and Design Technologies. We're an engineering design, analysis, and manufacturing company based in Tempe, Arizona, and we are a Stratasys technology reseller. I'm Pam Waterman, PADT's Senior Application Engineer for 3D printing. As noted in the previous webinars, the Origin 2 is a DLP resin printer based on Stratasys Programmable Photopolymerization, or P3, technology. It uses UV light to cure a wide variety of liquid resins from multiple third parties, and it produces strong end-use parts with injection molded quality. Today, we're talking software, specifically GrabCAD Print, how it powers this printer and simplifies your workflow. GrabCAD Print, commonly called GrabCAD or just GCP, imports more than 24 3D file formats, making it easy to bring in and manipulate models generated by a wide variety of CAD packages or produced through different 3D scanning systems. GrabCAD's standard version is also completely free. Anyone can download it and set up parts to print based on an Origin 2 template. This offers a great way to evaluate and learn the software long before owning the hardware. Any print files created with the free software can be saved and uploaded to print on any corresponding Stratasys printer. We'll list the website link for GrabCAD at the end of the webinar, or you can just search online for GrabCAD Print Download. This free version handles 4 of the 5 Stratasys 3D printing technologies, from filament-based FDM and droplet-based PolyJet to resin-based Neo SLA and resin-based P3 printers. The paid version, GrabCAD Print Pro, includes many additional features and also supports powder-based SAF systems, bringing the software to all 5 Stratasys printer technologies. GCP Pro offers advanced functions to simplify and speed up part processing. More about those later. All printer controls and choices, from material selection to job queuing, are found in Stratasys GrabCAD Print. The visual layout and simple toolbar progression let users jump right in with little to no training. Once a model is loaded, the software provides many options to repair files, arrange and orient parts on the build plate, add supports where needed, slice the job, provide build estimates, and send all build instructions to the printer. Let's walk through a software demo and break down the Origin 2 part setup process for 3 different CAD models: a threaded cable gland, the top half of a snap-fit battery housing, and a bracket with several non-90-degree angles. When you open GrabCAD, you'll see this window. The top left toolbar has general controls. The top middle toolbar has viewing controls, and the right side toolbar offers a step-by-step progression for processing a model. But the first thing I do is select the printer that I want to use. At the lower right, there's a box with a down arrow. Clicking on that arrow opens a drop-down menu with all possible printers, either already connected to your company network or available as a template. Remember, all Stratasys printers use GrabCAD Print. From here, you can go to the template selection and select Origin 2. Next, I bring in my model. There are 3 ways to do this. Click on File at the upper left and go to Add Models, or you can click Add Models in the New Project panel, or you can drag and drop a file to anywhere in the GrabCAD window. I've used drag and drop to bring in 3 model files from my own desktop. If you have a number of parts, as I do, and especially if you have more than will fit on a single build tray, you can move some to a second or third tray, still within this single job. That lets you set global parameters just one time and have them apply to quite a few parts while still individualizing per part parameters. I'm going to create a first tray setting up this threaded cable gland for an electrical cable connector assembly. So I can go to a different tray here, create a new one, and it's by itself. You'll see it has labeling and texturing on all sides. Let's look at the toolbar on the right side. Some of the steps are optional, so I'll take the simplest approach, starting with assigning a material to the tray. Tray settings is where this gets done. The default of Loctite 3D 3843 black, a rigid resin, shows up, but I can click on Change to see all the possibilities. For example, I can go to Preferred Materials and just choose BASF ST45 Clear. The next step is to consider if the part needs a support structure to anchor it to the build plate and support overhangs against gravity. I've started with a model with a flat base that can print directly on the build plate, and no other supports are needed. When I click Estimate at the bottom, I see it will take 1 hour and 8 minutes to print and use about 25 cubic centimeters of resin. A good rule to follow is to fill the resin tray with 200 cubic centimeters plus the amount needed for the part. So 225 cubic centimeters here. And now it's ready to print. Clicking on Print down here will send it to whichever printer I'm connected to on my company network. It could be in the same building or in another city. Now I'm going to set up the battery housing part that needs some support against gravity. I'm going to go back over here, click on this part, again, move it to a new tray. It's just a little easier to focus on. For this model, I want the outside to have the smoothest surface, and I want to minimize the need for support. So first, I'm going to rotate the part 45 degrees around the y-axis, so it's angled to the build plate. That means use this rotate orient section, and I said around the y-axis. I'm going to change this to 45 and rotate it. I've already set my material, same as for the cable gland. So coming down on the right, I'm going to click on Anchor Points. I can click Generate Anchor Points, accepting the defaults. These are the spots on the part where the breakaway sacrificial support structure will connect. You can rotate the view to see the arrows that represent all of these points. I will accept them and move on to Support, Generate Support. Clicking on the Generate Support does just that, again accepting default points. You'll see them generate, and then you can make a decision about whether you accept that. This part is well supported, and you can see the nice box structure of the supports. The model is now ready to print. Hitting Estimate here shows me print time will be 2 hours and 57 minutes. The model itself will use about 16 cubic centimeters of resin, and the breakaway support structure will use about 14 cubic centimeters. Now, starting over with the third example, I'll show creating the supports and doing a bit of editing. You'll see this model came in at an interesting angle based on the 3D view in the CAD design process. I talked to the designer to learn which surface was most important to be flat. So I'm going to rotate the part to print that section directly on the bed. When you use the rotate icon, remember that you had in the previous example the choice to enter degrees and an axis. But here I'm going to use Orient Face to Plane. This tool is one of my favorites to quickly make the important face the bottom. Select it here, click that, make it the bottom, and there you go. Now I'm going to click the Anchor Points tool. But when I look at the default anchor points, I remember I want to print this directly on the build plate. So I'm going to delete the points on the bottom surface like this. Rotate it so I see the bottom. Select just those points. and hit delete. Also, I think I want to add a few more anchor points along the sides, just to be sure I have a very stable part. This is easily done by rotating the view and hitting Control left mouse button wherever I want. Down along the side like this. I can also add a whole line of these by coming over and going into line mode. Click here, bring it down here, double click, and I'm done. Now I want to generate the supports, but first I'm going to change one setting, and that is distance from the build platform. I wanted it to sit directly on, so I'm making that 0. Now I'll click Generate Support. You can see the progress bar at the top, and rotating the view lets me see this looks good. Finally, I click Estimate and find the build time is 2 hours and 19 minutes. The model material is 7 cubic centimeters, and support will use up about 3 cubic, about 1.5 cubic centimeters. For all of these parts, I'll save the project, and then I can either switch from template to a networked printer and hit print for each tray, or I can export this slice stack. Unlike a filament type printer, where each slice involves G-code instructions for the print head movement, with a DLP printer, each slice is a PNG image file. That's what the Origin DLP printer flashes through the glass and the clear tray membrane into the thin layer of resin, curing a single layer at a time to form a complete layers pattern. Now, that's the basics. All you need to do to set up and run several types of parts and their optional support structures for a standard resin choice. But for those who want more control or more material choices, there's the Stratasys OpenAM material license for P3 technology. If I were to go back here to materials, you'll see that there are open exploratory materials as well as additional types depending on what you've signed off for. OpenAM lets you expand your printing options in several ways. First, more material parameters are unlocked for editing than the base settings in the already well-populated P3 material library. Or you could explore and optimize the build profiles of any resin of choice. This license gives power users access to advanced printer settings within GrabCAD Print that let you tweak parameters such as UV exposure level, build chamber temperature, build plate motion timings, and more. These next level settings are perfect for fine-tuning specific materials or improving throughput. You can even create custom material profiles, optimizing for speed or tricky geometries, and saving all settings as a new material profile. It's like unlocking a treasure chest of new possibilities for your project. In the broader picture of how an Origin 2 printer operates within your company's manufacturing ecosystem, GrabCAD Print offers job scheduling and viewing and resource analysis. Let's go back to the left side menu to view these functions. The first icon is all about setting up a print, which we've done. The second icon gives you job status for all of your network connected printers. Here you can see PADT has 10 Stratasys printers connected. For each printer, you can click on an individual job and see the details of the status, start time, finish time, and a view of the GrabCAD Print build tray layout. For Origin printers, you can also review previous builds. The third icon lets you view printer history for a given printer. Here I'm selecting one of our Origin 1 printers from the drop-down menu at the top. Here I can see the job name, the person who submitted the job, the date started and completed, the total print time, the material type, and the quantity of material used. I can also download and save all this information in an Excel spreadsheet, accessed here at the upper right. In a nutshell, the Origin 2 software is both user-friendly and powerful. GrabCAD Print makes printing straightforward, while an OpenAM license hands you the reins for customization. Together, they maximize what this printer can do. For a free download of GrabCAD Print Standard, go to https://grabcad.com/print/ and click on the Go to GrabCAD Print button. Once you create a free account, you can log in and download the software on any Windows PC or laptop. As I showed earlier, you can select a template version of any of the Stratasys printers, set up a part to print, and even save out the print job file to then upload separately to an actual printer. Reach out to PADT for more information about Stratasys Origin 2 systems. We are an engineering services company founded in 1994, and we provide simulation, product development, and 3D printing services, as well as selling and supporting Stratasys, ANSYS, Flownex, Geomagic, and Zeiss products. That's it for the technical side of our series on the Stratasys Origin 2 DLP resin printer. We've covered materials, capabilities, applications, and now software. Stay tuned for the final webinar in our series, where we talk the nitty-gritty of return on investment, ROI, for several different CAD geometries, answering the question, is this a good part to print on an Origin 2 or not? And how do I crunch the numbers to be sure? Feel free to email us with any questions. Thanks for watching.